Hello class, today we're going to learn about multiple regression model building, and the difference between this chapter and previous chapter is that in the previous chapters we have linear model, so it's a straight line, it's a linear model, and in this chapter we have quadratic model or we have square root model. Okay, so it's no longer linear. So in the example that we have here, we have x squared, and to test for the significance of the quadratic effects, there are two ways to do it. The first method is comparing the R-square of the simple regression model and comparing that to the adjusted R-square of the quadratic model. So that's the first method. The second way to look at it is look at the slope of the quadratic variable and seeing if it's significant or not. If it's significant, then we have quadratic effects. If it's not significant, then there are no quadratic effects. Example 1, determine which model is better, linear or quadratic. So in this question here, if we look at the diagram, we have time on the x-axis, and then we have purity on the y-axis. So time is your independent variable, and then purity is your y variable, is your dependent variable. So we're trying to see if time will affect your purity. When we look at the diagram, we can see that there is a curve-looking shape to the data set, but we're not sure if this is a linear model or a quadratic model. So we need to test that out and see which model is better. So that's what we're going to do right now. So in the Excel file, we're going to run the regression 2 times. So first we're going to run the regressions using a simple linear regression model. We're going to run it just with the x and the y. So x is your column C and then y is your column B. So we're going to run that simple linear regression right now. So we're going to use data analysis, right, regressions. So you should know how to do that by now. And then in the y, we have your B6 to B19. And then in the x, we have C6 to C19. And then we press OK, and then it will generate the regression equation for us. So now that we clean up the data from the regressions analysis, what we're going to use is we're going to use the coefficient. So we're going to use the y-intercept, and then we're going to use the slope. So once we have completed the simple linear regression, now we're going to run the quadratic regressions. And first step is what we need to do is we need to create a new column called x squared. And how we're going to do that is basically we're just going to multiply all the x by itself. That's one way to do it. Or you can just square all the x variables. Okay, so we're going to square all the x variables, and then we replicate the formula. And then now we square all the x variables. Okay. And when we run the regressions, what we have is that now we have two x variable. Okay, so now we have column C and column D. Both of them are our x variable. And then our y variable is the same as column B. Okay, so we're going to run the regressions. So now we're going to run the quadratic regressions, data analysis, regressions, and then you're going to highlight B6 to B19 for your y variable. And then for your x variable, what we're going to do is we're going to highlight the two columns, column C and column D, so C6 all the way to D19. And then we press OK, and then now we have generated the regression table. And what you see here is that, again, we have your coefficient. That's what we're going to use. This is your y-intercept, your x1, your slope 1, slope 2, and then we have your r-square, adjusted r-square, and so now that we have run the regression twice, first time with the simple regressions, second time with the quadratic model, we can see which model is better. And the first method is what we state is that we're comparing the r-square of the simple model, and then we're comparing that with the adjusted r-square. What we can see here is that the r-square of the simple model is less than the quadratic model's adjusted r-square. So therefore, we know that the quadratic model is better in this case.